39. Which graph best represents the solution set for this system of inequalities? Lots of keywords. We have a system of inequalities. If it was just one inequality, the solution set is a lot of points. I would have to shade the top or the bottom part. I would have to have a solid line or a dotted line, depending on whether the inequality includes the equal to or not. But a system of equalities, you have to do that for each inequality, shade this part, and then find the overlapping part. Okay, let's see what that system looks like. It's this one. Unfortunately, it's not y equals, y greater or equal, y less than. In other words, the y is not isolated in either of them. To fully believe those inequalities, I have to isolate the y, because whenever the y has a negative number in front of it, when I try to isolate it, this negative number, when I try to eliminate it, it's going to flip the inequality. Let's do an example here. Let's say it's 5x minus 2y less than 3. Y less than 3. I want to isolate the y, otherwise my graphing calculator is not going to graph it. Okay, so I would put negative 5x, and what I would get is negative 2y less than negative 5x plus 3. And then I would try to isolate the y by dividing by 2. But the moment you divide by a negative number, you got to flip the inequality. Okay, so I would end up getting y greater than negative 5x plus 3 divided by negative 2. You see, you start with less than, we end up with greater than. And so the moral is that don't trust what you are given before you check if the y has a negative number. If it's a negative number, that's going to flip, and it would be the opposite direction. Okay, now let's look at what I got here. The y in the top is here, and it has a plus 2 on the front. So I can trust this inequality. It's going to be less than after I isolate it. The second one, the y is here. Also careful, it's in the wrong order. First is the y. It doesn't have anything. That means it's a plus 1 times. In other words, it's positive. I can trust this inequality too. I'm saying that because sometimes just the inequality alone is enough to solve the problem. If that gives to more than one options that satisfy this, then I will actually have to isolate y and graph it and figure out what it is. But turns out here, so far, I can trust the inequalities. They are both less than, and I'll see if alone, that fact alone, can help me get the answer. Okay, less than, it's not equal, less than, so the lines are going to be sort of dashed for each one of them, and less than means shade the bottom part, and here the same, shade the bottom part. Alright, let's start with the dashed lines. Which one have both dashed lines in the graph? It's not the first one, and it's not the last one. So I'm between those two. Okay, I need to, now I'm gonna shade the bottom part, meaning below the dotted lines. If I shade this one below, I get this. That's not all. I need to shade the other one and then find the overlap. I shade this below, I get that. Where is the overlap? The overlap is here, and they have shaded this one, so that's not it. That means it has to be this one. I can double check. Shade this one at the bottom, and then shade this one at the bottom, and we see that the overlap is the same as the given part, so this is the correct answer. The solution set is this overlap. Any point that's in the shaded area satisfies both inequalities. Like if we plug in any point with any coordinates from that shaded part, I get two true statements, one true statement for the top and one true statement for the bottom. The dotted lines are excluded. Those would be true if there was an equality, because that corresponds to the equality. Alright, that was 39. Let's go to 40. Which graph best represents that? Okay, now I can probably figure this out without the graphing calculator. That could be a good opportunity to review the factor form. This is the factor form, a quadratic, and the factor form is this one: x minus x1, x minus x2. A is the A of the standard form, ax squared plus bx plus c. X1 and x2 are the two x-intercepts. Just by comparing, I see that that looks good is x minus something. That doesn't look good because this is x plus, so I'm going to rewrite this as x minus minus 1, x minus 3. If I compare, I see that x2 is 3. x2 is whatever is after the negative. After the negative is 3. So I know that one of the x-intercept would have to be negative 3. And the other intercept is whatever is after the negative. Whatever is after the negative is negative 1. Okay, that's good. And that could answer or not alone. I'll put it on the graphing calculator in a little bit, just because we may not remember or we may not want to do it this way. So I'm going to do it with the graphing calculator. But which one has x-intercepts negative 1, negative 3? Negative 1, negative 1, sorry. I made a mistake here. It's not negative 3. Whatever is after the negative is 3. So x2 is 3, not negative 3. Okay. So which has x-intercepts negative 1 and 3? The first one works. The second one has it backwards, gives the negative to the 3, the positive to the 1. That's not it. Then we have negative 1 and 3, that works. And this one is also backwards, negative 3 and 1. It's the opposite signs. So that's not it. And looks like I have to go between A and C. I can use the y-intercepts. The y-intercept here is 3. And here is something between negative 1 and negative 2. Probably is going to be the A, just because they don't like decimals, or if they have to, or not exact numbers. But A, I'm going to have to double check. How do I check? Well, it's like how we convert the factor form back to the standard form. We distribute, and that breaks all the parentheses. We put like terms together. But the y-intercept is going to be a pure number. It's going to come from multiplying those two pure numbers. And the best way to multiply is in this form, because I don't have negative negative. So 1 times negative 3 is going to give me a negative 3. That's going to be the y-intercept. And I see that it's this one, negative 3. Should be this. Okay. But how can I do it if I don't want to think really hard and I want to put it on the graphing calculator? Then I'm just going to go to the graphing calculator, and I'm going to put this given function and see what happens. You can write it as h of x or as y. Let's go here. I'm gonna put it first as h of x just to see a use for that. H of x, oops, h of x equals, and where was it? Okay, x plus 1 in a parenthesis, and then is x minus 3. That's gonna give me the values for the x-intercepts, which are -1, 3, and the y-intercept, which is -3, and that's going to be the answer. It's the one that I was expecting, the first one. So here's a use for putting h of x. If they ask you to, so what's the value for x equals, I don't know, -2? Or they may ask you what is h of -2. No matter how they're going to ask it, if you type it as h of -2, you get the answer. And that's one use. On the other hand, you type extra letters, you would get your answer like this, but then you wouldn't be able to figure out the value. If you need values, type it with f of x, g of x, h of x, etc. Okay, so even if you type it with a y, you're still gonna get the same thing, and you save some work from typing. Okay, well, that was 40, and then let's go to the next one, 41. 41. The first 6 terms in a geometric sequence. Okay, now that's a new one. Geometric sequence is really an exponential function, only it's not continuous. The graph is not goes on a continuous line. It's broken down. It's composed of separate points. Okay, are shown where a1 is -4, and then it's giving me a bunch of values. What are those values? Those are gonna be the y's. Okay, the terms of a geometric sequence, when it says terms, those are the y's. Okay, based on this information, which equation can be used to find the nth term of the sequence an? Again, there is a formula and all that, but the graphing calculator is not going to recognize this formula, so I'm just going to consider it as an exponential function, and everything's going to work fine. Based on this information, which equation can be used to find the nth term of the sequence an? Well, they just need to find the function. This x, imagine, is this n is basically x, and this an is basically y. Alright, exponential function, y equals a times b to the x, and I will need to find the a and I will need to find the b. I'm going to use the squiggly sign, the squiggly method to find to have the graphing calculator figure it out, and then I will try to match it, and I will do the obvious transition whenever it says whenever I say x is n, and whenever I say y is an. Fine, let's see if we can do that, but we need a chart for that. And what would the chart be? The chart would have x and y. Those terms of the sequence that are given, those are the y's. So I start with -4, go to -16, -64, and so on. Usually just 3 points are enough to find the exponential. Okay, and it doesn't talk about best fitted, best model, or anything like that. So I don't have to put everything. If it was a best fitting, then you put everything, otherwise you're not going to have the best fitting. So I'm just going to do only three of them because 3 points are enough for an exponential. Now the question is, what do I put for x? They don't give me anything. I should know that for geometric sequence you start with 1, 2, 3 and you keep going. Alright, there is no 1.1, there is um, the first term goes with 1, second goes with 2, third with 3 and so on. Alright, so let's put that table on my graphing calculator and see if it will help me figure out. Okay, plus sign table, 1 goes with -4, 2 goes with -16 and 3 goes with I believe -64. Let's double check that. I think it was -64. Okay, and then I remember y equals ab to the x. Of course it's going to be y1 space squiggly with a capital A, then b, wherever b is, b, and then it's going to be to the x 1, and it's going to give me what a and b is. A is going to be -1, b is going to be 4. So I know that a is going to be -1 and b is going to be 4. So the function that represents this geometric sequence, the exponential function that represents this geometric sequence is going to have -1 times 4 to the x. For usually we don't put -1 because times 1 doesn't offer anything, or 1 times doesn't change anything. It's just -4 to the x. This y is going to be the an, and this x is going to be the n. So which one we get? It's the last one. It's the second one. Okay, the last one has the negative inside the parenthesis. So it's not the same as this one. It's very different. You may say, why do we need to put this parenthesis here? We don't have to. We can also write it like that. Okay, we would have to put the parenthesis if the parenthesis includes a negative, then it needs to be put there, because then the n hits the negative and hits the number. If I don't put a parenthesis, if I don't put the negative in the parenthesis, the n hits only the 4. But if I don't put the parenthesis, n just hits 4 anyway. So it's not needed, but it doesn't hurt to put it. So bottom line, the correct answer is B, and it can be written either with or without a parenthesis. Okay, 42. What's the solution to this? Record your answer. Okay, that's a standard way of solving an equation. You convert it into a system of equations and you put it on a calculator and it will solve it. If there is a solution, there will be an intersection. If not, the lines are parallel, and if there are infinite solutions, one on top of the other. So I need two tabs, y equals for one and y equals for the other. When I put the left hand side on 1, I can even convert this q to x, if you remember to do it in both, but because you may forget and I may forget, let's just keep it as q plus 56.5 closing parenthesis. That's the left hand side, and now I'm going to put the right hand side, which is 30 q minus 112 and that's gonna give me, where are they? Let's zoom out. Okay, here it is. There is an intersection, there is one solution, and which is the solution now, 13 or 278? Well, I know that this is x comma y. I'm not looking for the y, I'm looking for the x. I just call it q here. Okay, the q plays the same role as x, and what is the solution? 13. So the solution is 13. Okay, and that refers to q. All right. Number 43. Which expression is equivalent to, oops, which expression is equivalent to this one? Now, what is that? This is the standard form. That's y equals ax squared plus bx plus c. There is no x. That means this b is actually equal to 0, and it kills the x, and it doesn't call it x, it calls it m. Fine. And what are those forms here? Those are factor forms. And what about the last one? The last one is both a factor form and a vertex form. Okay, bottom line, how do I find it? There are several ways. I can factor this one and see which one it matches. I can distribute each one of those, and then I'll see if it matches this one. Whenever we distribute anything, it's gonna end up becoming the standard form, because the standard form, this one, is perfectly distributed. There's nothing else you can do to it. But those are if I want to work really hard. Here I can just put it on my calculator, especially during STAAR. You don't want to take chances getting tired before you're done. So I'm gonna put it on the graphing calculator, and I'll see which two equations have the same graph. Now, why would they have the same graph? Because equivalent functions need to have everything the same, including the graph. Okay, so let's go and do that. Y equals, this would be the given one, 36, and I'm gonna write it as m squared to avoid making a mistake, minus 100. Okay, this is my function. I can change the scale 2 fingers on the vertical axis, and you can make it shorter or taller. First option, y equals parenthesis 9m minus 20, closing parenthesis, opening parenthesis, 4m plus 5, closing parenthesis. Now we look at the graphs, they don't match, so it's not it. Let's go to the next one. Y equals, you see that it's the y equals is not even given in the question, but we add it ourselves. If we don't put the y equals, especially in the first one, because we are not using x, it's not gonna graph it, so let's just put y equals in everything. Okay, the second option is 4, and then we have 3m minus 5, and then 3m plus 5. Oh, that's it. Okay, then it's the second option. This So this one. All right, let's go to the next one. 44. The table shows the net revenue in millions of dollars of a company every 3 months. Okay, that's good to keep in mind. An exponential function can be used to model the data. All right, we have the data here, and obviously here we'll have the x on the left, y on the right. If you the x is written here. Here it doesn't say y, it says r of x. Just keep in mind that usually we put x to the left, y to the right. How do I remember? Where left is before r in the alphabet, the same way that x is before y in the alphabet, if you forget. Which function best models the data? This, or this. There are four options. And here the keyword in the question mark statement in the question is best models. So it's not going to be exact. That is a best fitted, and what I'm going to find is a best fitted curve, a best fitted exponential curve, meaning it may not go through all the points exactly, but it's going to go close to those points. All right. There are ways to narrow it down. It may not matter because I will still have to put it on the calculator. But what I see here is it goes from 274 to 389 to 467. It's increasing. I know that the base is going to be greater than 1, but I see there is 1, 2, 3 that are greater than 1. So it's going to be one of those threes. If I want to eliminate, it's going to be this one is going to go. Maybe I should just write this just to review. Let's review over and over until we make sure we remember. A is the initial value, and that is also the y-intercept on the graph. When b is greater than 1, this is the base or the gross factor. This is multiplied every 3 months here. You multiply by this factor. That's why it's called growth factor. Depending if it go by 3 months, or if it goes by day, if it goes by year, if it goes by hour, it doesn't matter. Every time, depending what this x is counting, or here it counts as 3 months periods. It's increasing, and if it's less than 1, that's decreasing. And here I see that it's increasing. That means I expect that b is going to be greater than 1. This one has less than 1, so it's not going to be it. It's going to be between a, b, c. If I want to use a little common sense and I read those values that I got, I see here that after 3 months is 274, then 389. Well, what is initially? Initially is at 0 month. It's going to be less than 274. Do we have anything that's less than 274? Well, 223 is less than 274, but also 1 is less, and also 0.92 is less. I expect that it's not going to go from 1 to 274, but who knows? It could be. Just the most reasonable one is that the initial value is 223, and then it increases to 274, and so on. So I would choose this one. We're going to put it on the graphing calculator and see if that makes sense and what the graphing calculator is going to give me, because I may not be able to think any of that. Okay, I still have the graphing calculator. All right, let's go. I'm going to start by putting this table, and unfortunately I can't narrow it down. I can't cut it down to just 3 of them, because if it says best modeling, best fitted, or any of that, you have to put all the data. Otherwise, you're not going to find the best fitted. So 3 goes with 274. Then we have 6 going with 389. Then you have 9 going with 467. Then you have 12 going with 560. Then you have 15 going with 960. 18, 1100, 21, 1320, and 24 going with 1584. I hope I typed everything correctly. Now the next one is use the squiggly to figure out the function, and don't forget to put y1 and x1. y1 space squiggly, we have capital A, where we now b to the power of x, x1. Okay, so that gives me those values for A and B that I have at the bottom. This is what I was looking for. They may be rounded or not, but I'm going to write it the way it is and see how close I am to the answers given. But another thing to see, let's have a little visual here. You see, the function doesn't go through every point. It just fits the data as much as possible. Some of this data is going to be below, some of them above, some of them are going to be exactly. It depends. Okay, so this is the best fitted. If I erase it and you see this data and you try to approximate it with an exponential function or graph, that looks like it's gonna be it. All right, so just let's see what we got. 255,789. Okay, so we have A is 255.789. Looks good. It's a little less than 275. And then B is 1.08. And I'm not sure if I need really all the, let's just write it, 0.64. I see here everything is rounded to the second decimal, so I'm not gonna keep everything, and I'm gonna round this to 79. Okay, well, which one is closer? Oh, before we do that, let's see what we got now. We have A, we have Y equals, instead of A, I'm gonna put 255.79. Let's put it in a parenthesis, times B, which is, let's put that in a parenthesis here too, 1.08 to the x. So this is the equation of the best fitted curve. And earlier I said that's probably A. Well, I have 223. It's close enough to 255. I have 1.09. That's close enough to 1.08. This one is 1, is way off 255. 223, that's way off 1.8, so that can't be it. The other one I have already excluded it because it's 0.92, which is less than 1, but also I see it's the initial value is 2000, it's way off. And the last one, again, it's way off. 0.92 is really smaller than 255, and 2000 for the base is really much bigger than this one. Okay, So the correct answer is A. It's as close as it can get based on what I got and what they give me. Next one, 45. Which graph best represents this system of equations and its solution? Okay, that's a system of equations. This system of equation, if it after I graph it looks like that, has one solution. If it's parallel, no solution, and if it's one on top of the other, it's infinite solutions. Okay, just try to see what I expect. And I see that those are linear, meaning there's no squares, no exponentials. It looks like those are gonna be lines. Okay, so I have two lines, and how can I solve this one now? Well, unfortunately, if I try to use the calculator and I plug in those equations the way they are, it's not going to graph it. The regular Desmos graphing calculator is going to graph it, and then I can compare the graphs. But the STAAR testing graphing calculator, it needs it to be solved for y. In other words, need to write y equals and y equals, then it can graph it. So there is no way around it. I will have to isolate the y. Alternatively, if I didn't want to use a graphing calculator, I would take the coordinates of the intersection and plug them into both equations, and I should get a true statement for both. Then that would be the correct graph. But I'm going to use the graphing calculator since I should know how to isolate y, and it's probably less work and less possible mistakes than trying to plug in and potentially typing something wrong. Okay, let's start with the first one. Let's do it green. 2x equals 6 minus y. I need to isolate y because y needs to be by itself. How do I do that? Let's get rid of the 6. It's negative 6. I would first try to simplify left or the right by using PEMDAS. Then, but here there's nothing to do, no PEMDAS to the left, no PEMDAS to the right. So I'm moving things from left to right by using properties of equality, which tell me if you subtract something from one side, you have to subtract from the other too. If you add, you have to add, and so on. So this is what I do in this step. And if I do this, I get 2x minus 6 equals to negative y. I'm not done yet because this is negative y, I want y. But negative y means negative 1 times y. So I'm going to divide by negative 1 both sides. This negative 1 is going to go away. Now I'm going to change the order. I'm going to write the y first. Y is by itself now equals. I'm not going to try to simplify it. 2x minus 6 over negative 1. I have the y equals. It doesn't matter that this is not simplified. My Desmos is going to graph it. I'm not going to do an extra step. Potentially I'll make a mistake here. I stop. Now let's do the other one. The other one is this one. So I start with 5x minus 4y equals 28. I need to isolate the y. I can't do anything to simplify on the left. There's no PEMDAS to do. Same here. So I'm going to move terms from left to right, right to left, using the properties of equality, in particular addition or subtraction. Here I'm going to subtract 5x, and I'm going to get negative 4y equals negative 5x plus 28. Okay, I'm not there yet. This needs to be by itself. Again, properties of equalities, but now I'm going to do division or multiplication depending on what I need to do. I have negative 4 times x, so I'm going to divide, only I'm going to have to divide both sides, and I will get y by itself, and on the right negative 5x plus 28 over negative 4. I'm going to leave it like that, and now I will be able to to graph it. Okay, let me get it set. Okay, let's go on the graphic calculator, and I'm going to have y equals, I need both of them, two of them, so two tabs. The first tab is going to have the first equation, and that was 2x minus, it's better to, now if you start without the fraction line and put 2x minus 6 and then you try to divide by negative 1, you may accidentally write it like this, and that could be wrong. So the best way to do it is start with the fraction line. You get the fraction line by tapping the division symbol, and now you have 2x minus 6, and at the bottom it was negative 1. Okay, well, where is the line? Here's the line. Tap the home button over here on the right, and then you'll get it. If you accidentally are on the wrong scale, it's going to try to get you, and if not, look for it, and because it may be off the screen. Alright, another division symbol. Here we're going to put negative 5x plus 28, and it's divided by negative 4. Okay, here's the other line. I see the intersection point. That's the solution, meaning the solution is you have to plug in 4 for x and negative 2 for y. It always goes x comma y. So the first one we have to plug in for x, the other one for y. But that's what it means. It doesn't ask me to find the solution. It asks me to match the graph. I'm going to start by checking where this intersection point is. It's in the fourth quadrant. So let's see which graph has the intersection point in the fourth quadrant. Well, I see that this one is in the first quadrant. This is the first quadrant, so that's not it. The second one has the intersection point in the fourth quadrant, and I'm not sure if I said third and fourth. Obviously this is the fourth quadrant that the intersection point is, but looks like that could be it, because that looks it's in the good place. I'm saying this because sometimes you don't even have to check the coordinates. Of course I'm going to check the coordinates, but sometimes just by the location of it you can immediately tell. That's probably going to save a little bit of time. Now I look at C. The intersection point is on the second quadrant. That's the second quadrant. That's not it. And if this is not on the fourth quadrant, I don't have to read the coordinates. If this was also on the fourth quadrant, then I would have to read the coordinates and potentially do whatever else I could think of to narrow it down. But this one is in the third quadrant. That's not it. So there's only one in the fourth quadrant. That would be the correct answer. If I want to check the coordinates, I see that it's below 4. So 4 when it comes to x, so 4 it goes first. Next to negative 2. Negative 2 is on the y, so it's 4 comma negative 2. Let's double check here, and I have 4 comma negative 2. So that's the correct answer. Okay, let's go to the next one. 46. Which function is equivalent to this one? Is it that, this? Well, I'm not going to think of it really hard. It says equivalent. Equivalent functions have the same graph. So I'm going to plug in the given function and compare its graph with the graph of each one of those, whichever has the same graph as the given function. That's the equivalent one. Let's do this. It says k of x, but I'm just gonna put y. Is not gonna make a difference. X squared plus 2x minus 15. That's the given one, and I can make it more visible by changing the scale. Start with the first one, y equals, it says k of x, but as long as I put y equals, I get the same job and I type less. K of x is equal to x plus 1, parenthesis x minus 1. That's a different graph, okay? So that's not it. On to the second one, y equals x plus 1 and then you get x minus 15. Wow, that's way off. So that's not it. Let's do the next one, y equals x plus 5, x minus 3. X plus 5, x minus 3. And it looks like this is the one. They are exactly identical. So the correct answer is option C. Okay, now let's go. Yes, there's nothing really else to do here. Let's go to the next one. Which graph best represents part of a quadratic function with domain of all real numbers less than -4? Maybe we should review what domain is, and always whenever we talk about domain they could also ask me for the range, so those go together. Okay, domain, range. Domain goes with x, range goes with y. X represents inputs, domain is all inputs or all x allowed. All outputs, where are the inputs? They are on the horizontal axis. Where are the outputs? On a vertical axis. What does horizontal mean? Means left, right. What does vertical mean? Up, down. Now if you remember how those are related, notice that all the initials on the left are before the corresponding initials on the right in the alphabet. So D is before R, X is before Y, I is before O, H is before V, L is before U. Okay, so that's a way to remember. But let's see what we got here. Domain means X, less than, and the greater opening is going to go on the other side because this is going to be the small one, less than -4. Okay, that statement, how does it look like on the graph? First of all, X is horizontal, so that's the horizontal axis. Suppose that this is the -4. It's less than, it's not equal, so there is a hole here. It's going to have a circle to indicate that this -4 is missing, it's not included and less than -4 is on the left. Anything that's on the left is smaller than anything that's on the right. So here is how it's going to look. This is the graph of the domain. Let's call it D. This is the graph of the domain. So when I project on the x-axis to find the domain, I'm going to have to end up with something that looks like that. Okay. Now let's look at A. Here I don't even have a, what was that? -4. I don't even have a -4 number, so I can just cross it. But as a practice, I want to find the domain. I notice there is a little circle here. That means this point excluded, and it's going to project on that point also included. So the origin is excluded. Now the rest of the points are included, and as I project, and especially since keeps going forever, I'm going to end up covering this part. That looks kinda like what I want, but it doesn't start at -4. It starts at 0, so that's not it. The next one, let's project. I have to project on the x-axis because that's where the domain. I project like that. This point doesn't project. It's already on the x, but it's missing. There's a hole there, and as I project, I cover this part of the x-axis. That looks off. It should remind us that it should open to the left of -4. Okay, that doesn't look like that at all. It opens to the right of, it is a -4, but it opens to the right, so that's not it. Well, let's see. Here we got a -4, and it's missing because there's a hole there, so it doesn't project, but the rest are projecting, and I end up covering this part. That looks like what I want. It's -4. It's to the left, so it's less than -4. The -4 is excluded, so it's not equal. It looks like this is the answer, but I'm going to check the other one just to make sure. This point is missing, so it doesn't project to anything. I'll put circles, and as I keep going here, I see that it starts at 0 going to the right. That's not it. Okay, so I have figured out is C, and that was 47. Now let's go to the next one, 48. The graph of a line passes through the points -3, 1, 5, 8. What is the slope? Okay, let's convert those points into a chart. It's -3, 1, 5, 8. I'm not going to try to use the rise over. I could plot those points, use the rise over run, or use the y2 minus y1 over x2 minus x1. Even if I know how to do it, I may do some little mistakes. So I'm just going to go to the graphing calculator and ask the graphing calculator to find the slope for me. The question is, how do I find the slope? Okay, so it's going to be with a squiggly, but how is the squiggly going to find the slope? Well, let's read it carefully again. The graph of a line is y equals mx plus b, passes through those points. What is the slope? Well, if I know the line, then this m is the slope, and of course, if I was looking for the y-intercept, that would be the y-intercept. It would ask me for the y-intercept as well. So I'm going to ask from the calculator, utilizing the squiggly method, to find this equation, and then from this equation I'm going to read what the slope is. It's actually going to find the slope explicitly. But I see some fractions here, and let's see what the complication is going to be. Alright, so let's go to the graphing calculator and give it those values. plus sign table, and I have negative 3 that goes, oops, that was negative 2, negative 3 that goes with 1, and then I have 5 that goes with 8. Okay, now it's y equals mx plus b, but I don't have y, I have y1. If I wanted to read this table, I need to tell it to look at the y1 space squiggly, and then m, then x, x1 plus b. Okay, that's it. I see that the slope is 0.875, but if you look at my options, they're all fractions. So if I'm lucky, this is not an infinitely long decimal that has been approximated, because that's gonna we'll have to do, and we'll have to look differently how to find the fraction. It's just an exact decimal. That means it can be converted to a fraction. So okay, I see the slope is 0.875, but I want it as a fraction, so let's type it. 0.875. Let's tap the fraction symbol, and it's the 7/8. Okay, let's put the b, because maybe in a different question they will ask me for the b, meaning the y-intercept. How do I do it? All right, the same thing. Let's type it as 3.625, and let's convert it to a fraction, and that's going to be 29/8. Okay, so it's 7/8, 29/8, and that's what I got, 7/8, and b was 29/8. If I wanted to write the entire equation, here I just need the slope, but if I wanted to write, that would be 7/8x plus 29/8. Well, what about the slope? Do I have 7/8 option? Yes, so it's this one. What if I would get a rounded number that was 0.9, for example, instead of 0.875? What if it was rounded to 0.9? How would I find it? Well, we would put the options one by one, and when I put the correct option, which was 7/8, I would see that that would be close to 0.9. Okay, so that's, I could go the other way. I would type the fraction and see if it matches, but here I got the fractions already. I don't have to do that. Okay, that was number 48. Bye bye number 48. Let's go to number 49. A mail carrier delivers mail on one of two different routes. A morning route, that's probably going to be morning route, that's probably going to be the X, or an afternoon route, that's probably going to be the Y. Each workday the mail carrier is assigned one of these two routes. Last month the mail carrier delivered mail on the morning route 16 times. So here I get morning is 16, and on the afternoon route, afternoon 12 times, and then we get the total distance traveled is 141. Okay, it's not giving me the equation, so I'm gonna have to write it myself. Let's write it based on this one. 16 times the morning route. What's the distance? Well, it's 16x. Okay, x is the distance of the morning round 16 times. Okay, um, and on the afternoon 12 times. So what's the distance? Is 12 times y. 12 times the y, which is the distance of the afternoon route. The total distance, and that's 141 miles. Okay, now let's read the next one, next sentence. This, and I can erase that. Oops. This month, the mail carrier delivered mail on the morning route and 10 times, and on the afternoon route 59 times, and the total distance is 123. The total always by itself, so let's just put it there. X times 10, or 10 times x, because 10 times the route. So what's the distance? Is 10 times the distance of a single round, plus 15 times the afternoon route. What's the distance? Well, it's 15 times the distance of a single afternoon route, and that's the equation. Now, what is the distance in the morning round of the morning round in miles? Well, I have the equations, but unfortunately that is not going to graph it. I have to convert them into y equals format. So let's take this one, put it somewhere here, and let's take that one, put it somewhere here, and I will try to manipulate this each one of those equations in order to become y equals. The steps are the usual steps. I need to isolate the y, so after I see if there is anything else to simplify just on the left or just on the right side, I'm going to get rid of the unnecessary terms. Starting with 16x, I have to subtract properties of equality, so I'm going to subtract both, and then I get 12y equals negative 16x plus 141. Y is not by itself, so I have to divide by 12, and then I get y by itself, negative 16x plus 141 over 12. Okay, and then I do the same for the other one, exactly the same. Properties of the it's too low, let's move it a bit. I get negative 10x both sides, and that's gonna give me 15y equals negative 10x plus 123.75. Then another property of the equalities, only this time, is the division. So I divide both sides by 15, the entire left and the entire right hand side, and what I get is y equals negative 10x plus 123.75 over 15. I'm not even going to try to simplify that, but I don't need it because my graphing calculator is going to graph it no matter if it's simplified or not, as long as it's written in the y equals format. So what do I do now? Let's go to the graphing calculator, and I will have two equations, y equals in one tab, y equals in the other tab, and I will try to find the I will put the equations, get the graph, get the lines, and find the intersection. So the first one was 60. No, let's here. I'm gonna put first the division. I'm gonna hit the division sign because that's gonna give me the fraction line. So it's I believe negative 16. I will double check. Negative 16 x plus 141, and you divide by 12. I think that was the first one. Let's double check. Negative 16x plus 141 over 12. Alright, and the next one should be negative 10x, and then oops, let's put the division sign first. Okay, I have the line, the fraction line. Now I have negative 10x in the numerator plus 123.75, and in the denominator is 15. It's double checking. Negative 10, 123.75 and 15. Okay, now what do I need? I need the intersection. It looks like the intersection is right here. Those are that's the solution to this system. But which one do I need now? Do I need the x or the y? Well, x is the morning distance and y is the afternoon distance. If I need the morning distance, it's 5.25. The afternoon distance is 4.75. I'm going to write it down, both of them, just because I don't know what they may ask me in a different version of that problem. So based on what I did, I found that the x, which is the morning distance, is 5.25, and of course that would be miles. Let me restate that. 5.25 miles. If they were asking for the afternoon distance, that would be the y, and I found that it is 4.75 miles. Okay, what do they ask me? What's the distance of morning route? Okay, morning route, do I have a 5.25 anywhere? Yes, so that would be the first answer. Okay, now what was important in this problem that they did not give me the equations. I have to figure out how did I figure out. Now keep in mind that the total always go by itself. Total distance 141 and total distance 123.75 in the original equations that I wrote were by itself on one side. That's usually what we expect, unless they really want to complicate things. Then I have to clearly indicate what is x and what is y. I chose morning x and y and afternoon to be y. Then I have to relate the numbers given with the x and the y. But what was that x exactly? Let's see. That x looks like it's gonna be distance, and that would make sense because they give me miles the total, and this is 16 times. So 16 times the distance of a single morning route plus 12 times the distance of a single afternoon route is 141. So we have to, even if we can write the equation without even fully checking all the significance of for the x or the y, because they're going to ask me, it's good to keep in mind that x is the morning distance and y is the afternoon distance. And just associate x with the correct number. Here 16 going with x, 12 goes with y, and then let the calculator does its job. Okay, we are getting closer. We're at 50 now. 50 quadratic functions P and Q are graphed on the grid. The graph of P was transformed to create the graph of Q. So I started with the graph of P, and then I got the graph of Q. What was the graph of P? Now it's this one, and that one is the graph of P. They call it P because this is really the parent function. And the graph of Q, and it starts with a P. I mean, parent starts with a P. Now, Q is this graph. It's good to indicate. So I want to get there. And this is the transform function. So you take the parent function, you shift, stretch, compress, flip, whatever, and you get this graph. Okay, that's fine. Now if you compare this graph, the transform graph, if you compare it to the parent function, it looks flipped, up, down, so vertical flip, and then it shifts up. Okay, here we can try to figure out how it's going to be without even looking at the options. If we know a little bit about transformations, and we know that the parent quadratic, it says quadratic, so the parent quadratic is the simplest quadratic, y equals x squared. Maybe I should put it with orange. That would be the parent quadratic. But then it's flipped and shifted. Now, what do I want? Do I want to flip it and then shift it, or shift it and then flip it? It depends. It matters. But usually they're going to give me the simplest version, which is first flip, then shift. So this is how I'm going to do it. So first I'm going to flip. And if I flip, that's like putting a negative in front of it. Don't put it in a parenthesis with the x, because that's going to flip left, right. I want to flip up, down, vertical. And then I'm going to shift. So it's a vertical flip. Then I'm going to shift up. And I'm just going to add 2. So I expect that this is the correct answer, which matches D. But on the other hand, also before I get there, also don't put the plus 2 with the x, like x plus 2, because if it's with the x in the same parenthesis, that's going to be horizontal, and plus means go to the left. If it was negative, it would go to the right. I want a vertical shift, meaning shift up, so don't put the plus in the wrong. Now, I know the answer, but what if I don't remember the theory, or if I want to confirm, or if I just don't want to think really hard? Then I would go on my graphing calculator, and I would put one by one those options, and I would check which one matches the blue graph. Okay? Oh, well, let's do it. So I have, now it calls it Q of x, but I will, there's no reason why I should call it Q of x. I'm calling it y to type less characters. Y equals negative x minus 2. That's going to flip left, right, because it's symmetric. It's not going to appear flipped. Sorry, it's going to be flipped vertically, but because it has the -2 with the x, it's going to move to the right. So let's see if I got it. So yeah, it's flipped. This negative is out of the parenthesis. This negative here is outside of the parenthesis. So it's still going to be a vertical flip. It's not inside the parenthesis associated with x. The -2 though is going to shift it to the right, and that's not it. I want it shifted up. Now the next one is again y equals negative. So it has a negative that's going to be flipped vertically up down, but then the +2 is inside the parenthesis, and that's going to move it, shift it to the left. The x behaves in a opposite way than we expect. We add something and moves to the left, which are the negative numbers. We subtract something and moves to the right. So I expect that this one is going to shift to the left, even though I add. But that's not it. Now I'm thinking, oh well, maybe it's the next one. But it's not going to be, because when you put x squared, you put -2, the y, it behaves according to common sense. You subtract 2, it's going to go down. You add 2, it's going to go up, as opposed to the x. So I don't want it to be going down, because you see it's less than 0. That's not what I got. What I got is y equals -x squared and then +2, and that's going to be up. So if you see it, fine. If you don't see it, put it in the calculator and read carefully. Now next one, what is the solution to this equation? That is a standard technique. You put y equals the left hand side in one tab and y equals the right hand side on the other tab, and find the intersection point. If there is no intersection, there is no solution. If one is on top of the other, there are infinite solutions. But they are trying to confuse me here. They put a y, and I know that I always need to start with y equals, and if I put y equals that, the left hand side, and there are y's all over, the graphing calculator is going to get confused and it's not going to graph it. So when you see y, that's not good. Immediately change it to x. So write it like that instead. 40 minus 5x. And be careful when you plug it in, to plug it in as x, not as y. If you start with y equals, then you can have it as y. Alright, so I'm going to write it like that, y equals, and I'll be careful to, when I type, to type what they called y, I'm going to type it as x. Okay, 2, and then 40 minus 5x, and then I'm going to put y equals 10x plus 5, 1 minus x. Okay, now my advice was always to not change the name of the variables, because we may type something wrong. Here I told you to change the variables from y to x, because we are used in always starting with y equals. If you wanted to maintain the y, then don't put y, because y equals, because see what happens if I put y equals. It's confused, it doesn't know what it is. If you want to maintain the y though, you have to put x there. It's gonna may look different, but if you do the same thing on the other one, then you'll get the correct answer. Um, so I'm gonna do it both ways just to get convinced that we're getting the same answer. So the first way, I'm replacing what they give me as y, I put it as x, and then y equals as usual. Now what is the solution here? Let's change the scale a bit, find the solution. And now which one should I choose? Because I have 5. Well, 5 goes with x, 30 goes with y. Okay, it's x comma y. So 5 goes with x, but my x is what they call y. Alright, and if you look, uh, they're looking for the solution to this equation. That's the key word. The solution is a y, which I called as x. So and in my notation that's first, so the answer should be 5, should be C. Okay, now what I'm gonna do is I'm gonna keep the y, uh, which is how they gave it. Let's keep the y and then keep this as y. This is what they gave, but you see that now it's all, the calculator is confused. So I'm gonna change the x, the y as x. Instead of writing the usual x equals, the usual y equals, I'm gonna put x equals, because I can't have y equals and then have y on the other side. It's not gonna do it. Now, so that is okay. It can graph it, all right. But now let's see where the solution is. The solution is here, and if I tap it, you'll see that the 5 is on the y now because I didn't make any change. So if that works best for you, you can type y the way it's given, but then it needs to be x equals, not y equals. Okay, so if you put the y on the right hand side, it needs to be x equals, and then you know you're looking for the y, so look at the second place. It's x comma y, then you look at the y in the second place. Either way you do it, the answer is 5. We're getting closer to 54. 52. The initial value of a home is 200,000. The value of the home will increase at a rate 6% each year. Okay, that's an exponential function, and it's of that form, a times b to the x. We know that a is the initial value, on the graph is the y-intercept, and here is equal to 200,000. I am not going to put 200, 000 to remind myself to not do it on the graphing calculator. The graphing calculator does not like commas in thousands, because it thinks it's a point, it thinks it's an x comma y, and it gets confused. So don't put a comma here. You can write it, but don't put it on the graphing calculator. All right, B. Let's see what we got. It increases. That means b is greater than 1, because greater than 1 means the function is increasing, as opposed to less than 1, that would mean decreasing. So that's not it. I have a b that's greater than 1. 200,000 is the initial value. What about this 6%? This 6% is the rate. Is 6%. I can write it as 6 over 100, which basically is 0.06. Well, I don't know, how do I get that? All right, let's put it here. 6% is 6 divided by 100 is 0.06. Why do I need this rate? Because the rate is related to the base. An increasing base is equal to 1 plus the rate, and that is in my case is 1 plus 0.06, which is 1.06. If it was decreasing, it would be 1 minus the rate, but that's not what I got here. Okay, so what do I have here based on this data? Y is A, which is 200,000 times 1.06, which is the base, to the x power. Now I have a lot of information, and I was even able to do that. Okay, and we should be able to utilize this form of the exponential, and based on the data write down the exponential function. Now that we have the function, we can check and see if, without even putting on the graphing calculator, I can eliminate some of them. First, I'm going to start with the 200,000. That's the initial value. This one passes the test. That could be it. A is okay. This one starts with 100,000. That's not it. So it's not B. C also starts at 200,000. It can be. This D starts at 100,000. That's not it. So it's between C and A. Well, what can I say? They're both increasing. This one is a little steeper than that one. If you just want to use common sense, and we're talking about a home, and what else? The value increases. Looks like within, let's say, 2.5 years, the value becomes sort of 3 times more. That's not very realistic. It can, who knows. This one is a little more realistic, so without just using common sense, I would say that within 5 years, going from 200,000 to 260,000, that's probably more realistic than becomes 3 times more within 2.5 years. So I would say A, but I have the function, and I'm going to plug it in and see what my graphing calculator thinks about this. So here I'm going to put y equals 200,000, and what would happen if I put the comma there? It's going to give me something. It's like, oh, points are written like this, 1,2. It thinks it's a point, not a value. So I'll get rid of that, and then we have the base 1.06 to the x, to the x. Well, there is no graph. Let's see if I can figure it out. Oh, here's the graph. But look at the scale. It goes 200 on the x, 200. Every big division is 200. Looks like I have the same scale on the x and y. Look at my scale here. Let's look at the first one that I suspect it's the correct one. It goes from 0 to 25, 30 on the x, and 0 to 1,000,000 on the y. So if I even want to compare it or even find the y-intercept or any of that, I have to change the scale. So I'm going to make it, I want to reveal 1,000,000 somewhere here, and 2 fingers on the vertical axis, and you can stretch it or compress it. Okay, I have 1,000,000 somewhere here. If I make it a little bigger, I may be able to get 900,000. It's not really that important. Okay, now the x scale is not very good. I need to make it about 25 in order to compare, and I'm not zooming in or out. I'm just stretching or compressing the horizontal axis. So I think that's more or less good. So now that I have the right scale, I could check with what I'm given. It's pretty good resemblance. it does not resemble this one. This one has the same scale, goes from 0 to a million, 0 to 30, but it's way steeper. And you may say, well, I'm not convinced exactly. So let's take a point that could represent its graph. The 200,000, do I have this? Let's make sure. Yes, I have that point. Is the 200,000, that's the initial value. It looks like as the y-intercept on the graph. Is there another point that I want to check? I want to check this point here. That is approximately 15,500,000. Let's not put a second comma here. So the graphing calculator is right. So it's 15,500,000. What happens on the 15 on the other suspected graph? Here I was suspecting that this could be correct. Let's see. If I go to 15, that's off the screen. It's probably millions or billions because it increases really fast here. So the 15 is not even on the screen. So let's see if what happens in my graph. Is the 15 on the screen and close to 500,000? How do I do that? Well, one way is to create a table. Let's eliminate all the points because I only need really one point. And that point is the 15. Is it close to 500,000? Yes, it's 479. Where is it? It's right there. It's in the screen. Okay, so that looks like I'm good. Is there another method to do it? Well, another method is you may tap the graph and then you can scroll your finger until it goes close to 15 and you can see where it is. That's not very safe because you may not be able to read it or something. Another way is to just type x equals 15. It's going to give you an intersection that you can easily tap, and you will see that this point is the same as what you would get if you put a table. So either way you could get that point here. Well, everything indicates that this is the correct answer. All right, two more. 53. A coach has 96 golf balls for a school's golf team. The coach will give each player of the team 8 golf balls. The graph shows the linear relationship. Okay, linear, that's a key word. Relationship between y, the number of balls. So y is number of golf balls, and let's put number of golf balls and remaining on the team, and x is the number of players. X is the number of players, so x on the horizontal is number of players. Fine. What do we want? The coach will use no more than 6 players on the school's golf team. Which set best represents the range of the function for this situation? Now, even if I didn't know any of the what represents what, and I just read the word range and then I have this graph, I can answer. So I'm gonna forget what x and y is, and I'm just gonna keep in mind the word range. Of course, we have discussed this several times, what domain and range means, and they could also ask me for the domain, so I'm going to find both of them. Domain, range. Domains goes with x, range goes with y. That's enough here. I don't need to go farther than that. Although I could use one more. The x is on the horizontal axis and the y is on the vertical. So when I'm looking for the range, I need to look on the vertical axis. Okay, what does that mean? How do I look for it? I project on the vertical axis. So here is a discrete function. It's not a continuous, so each point projects separate. Let's start with that point. When I project on the y-axis, stay where it is at 96. This one goes between 84 and 96. That goes between 72 and 84, exactly at 72, more than 60, less than 60, 48, and that's it. So the range would be a set. This in notation here with the brace indicate a set, like a collection of something, a list of something. Those could be numbers, would be anything. In this case, there are just numbers. Okay, so this set will have all the numbers that I got in the projection. It's going to be the 96. Then it's going to be something that is between 84 and 96. But with this information, the 96 that I know is in the set, I'm going to try and check which ones I can eliminate. This one has 96, remains. The second one doesn't have a 96, so it's gone. The third one has a 96, remains. The fourth one doesn't have a 96, it's gone. Alright, then let's keep going with the obvious numbers. I have a 72. Okay, which one has a 72? I'm between A and C. Does A have a 72? It does. It remains. C, it remains. Okay, then I have a 48. They both have a 48? Yes. Okay, then that's it. Well, the first one has a 36 and a 24. That is not it. So the answer is C. So comparing this data, these numbers with what I got, let's try to make sense. 96 is 96. 88 looks like when I project here, I hit the 88. Now I know. It's a little over 84. A little before, a little less than 84 is the 80. So here what I hit when I project is 80. Then it's 72. Then I go to 64. Makes sense. Then 56. Makes sense. A little less than 60. And 48. 48 is 48. Okay. So it looks like I got it. And I have the rest of the data there. Now what if I wanted the domain? What would I do to find the domain? Because they can ask me anything. If I wanted to get the domain, I would project on the x-axis. Remember, domain goes with the x. I project on the horizontal or the x-axis. So I will get a 6, then a 5, then a 4, 3, 2, 1, and 0. So yes, that is the range. The domain, it's just 1, 2, 3, 4, 5, 6. So and I forgot there is also a 0. So let's start from here. 0, 1. So it looks like the last one would be the domain if they were asking me for the domain. Okay, we're almost there. Actually, this is the last one. Alright, the last one. Linear function. Linear. It's good to know. Has a 0, has a0 of -2, a0 of -2. What is a 0? And the y-intercept of 6. I know what y-intercept is. Well, let's see what 0 is. A linear function looks like that in one of its forms. Y equals mx plus b. What they say, what they call a zero, is actually the x-intercept. How is that? Well, to find the x-intercept, when you have the mx plus b, for example, you have to set y equals 0, and then you write it like that, y equals mx plus b. Because to find the x-intercept, because it's on the ground, y equals 0. And then you solve this equation, and you get the x-intercept. But because you set y equals to 0, sometimes the x-intercept is called as 0. Also, because you solve this equation to find the x-intercept, sometimes the x-intercept is also called the solution. So what is the information that we got? Well, the x-intercept is -2 and the y-intercept is 6. Let's see which graph has -2 as x-intercept and 6 as the y-intercept. Now you may say, okay, where is the x-intercept? Well, the x-intercept is on the x-axis, which is horizontal, meaning goes left to right. Okay, so x-intercept is going to be on the horizontal axis. Look at the first graph. The x-intercept is 3. That's not it. The y-intercept is 6. Yeah, that's good, but that doesn't work, so it's not A. In the second graph, the x-intercept is -2 and the y-intercept is 6. That could be it. This one, the x-intercept is 6. That's not it. The y-intercept would be -2. It's backwards, so it's not it. Of course, I have already found it. That's the correct answer. I have 2 points, a line. There is no other line that goes through that has that x-intercept and that y-intercept other than this line. So that's the correct line. But I'm trying to see if how to eliminate the rest, or just double checking what they're doing here. And number 2 is the y-intercept, -6 the x-intercept. Okay, obviously it's all wrong, and that is the answer. Again, the moment you see that you have 2 points, that's it, because you only need 2 points to uniquely define and determine a line without any possibility that there is another separate different line that goes through those 2 points. Like you have those 2 points, that's the line. There is no other line that can go those 2 points, and we have those 2 points here. Those are the correct points, so this is the correct line. We didn't have to look, we didn't have to check the remaining ones. Okay, that's the end. I hope you enjoyed it, and good luck.